outline, we are going to discuss about the authentication first of all. We are not discussing about the user authentication here. We are discussing about the message authentication. Then we will be knowing about modification detection code and message authentication codes along with its security. Next, we will be having some knowledge about few MACs. So we have two types of MACs here. One is with the hash functions and the one is with the ciphering, I mean the encryption procedure. So let us start moving with this. Message authentication. See, message authentication is nothing but who is sending the message exactly. So once I send one message to the receiver, I can claim that I didn't send this message to you. And receiver will be keep on claiming that you are the sender, you have sent this message. This kind of non-repeatization attacks may happen anytime, right? So for this kind of situations to be in a proper way, we must have this message authentication in our hand. So message authentication is nothing but when we are creating the message digest, along with the message digest, we are going to give some signature of the sender on that particular combination of the message and the message digest, right? So message digest solo, only message digest is not given with the authentication procedures. So thus we are going to include few cryptographic keys in that to identify that. So this is the main aim of message authentication. Now there is 2 points such as MDC and the MAC. MDC is nothing but modification detection code. See, modification detection code is directly striking to the checking with the integrity. So when we strike with one hash code sent by the sender and the other hash code receiver generated is not same, then we can say that that is not the proper message sent by the sender. So this is a procedure done by modification detection code, right? So its job is to check only the message integrity. Now we have another thing that is the message authentication code. So message authentication code is nothing but we are going to talk about who is sending the data exactly, right? So this is about modification detection code. In the modification detection code, we are going to check with the integrity. There should be no message changing, right? So in this, to go with this, LS is the sender here, and we have the plain text. This plain text we are going to give to the hash function. Thus, the hash function is provided with the message digest, right? So this message digest through the proper communication channel, we are going to send to the sender. Now, receiver. And the receiver received this, he will be keeping aside. And through the secure channel or unsecure channel, we will be getting our data, right? So now the message received by the receiver, he will take that data and apply same procedure which the sender does. So apply to the hash function. So he will be generated with the message digest. Now this is the receiver generated one. This is the sender generated one. If these two are same, then we can say that there is no modification of data. If not same, obviously there is an intruder between these two channels. I mean these two users. The modification of the message has been happened, right? So this is a procedure done, which is done by MDC. Now, what is MAC? Message authentication code. See, message authentication code is nothing but where this data has been started, who is sending this data exactly. And also along with that, we need to check with the integrity also, right? So how we are doing this with a single point is with one key concept, right? So here, this key concept may be either symmetric or asymmetric. If we are discussing as one of the sample here, we are discussing about the secret key, that is a common key for both the sender and the receiver. We can do this with respect to the asymmetric type also with the key pair, that is public and private key combination, where we call this type of situations as digital signatures, it's a schemes and public key type of thing. So now, as of now, you just be free with the secret key, which is a common key for both of them, right? So here we have one message, then we have one key. Both the message and the key combination we are going to give to the hash function. Now with this we got one MAC. Now with this MAC we are going to attach directly to the message whatever the ciphertext we got. Like if it may be the plain text, here we have shown the plain text. So few reasons will be there, like if it is insecure channel, we can go like this. If it is secure channel, we have to encrypt this one and give the ciphertext here. And this message digest will be like this only, right? So now we have the message and its digest. Okay, MAC, authentication. M plus MAC, we are going to send to the receiver. Now receiver received this data along with the message digest. Now this is a sender sent, just separate these two and take the message. Now, as we are discussing about the symmetric key type, same key, right? Take this message and key same and apply again to the hash function. Now, after applying to the hash function, you will be generated with the MAC, right? Now, this is a receiver generated one. This is a sender generated one. If these two are same, there is no modification of the data happened. So we can accept the data directly. Bob can accept the data directly. If it is not same, then Bob has to reject the data and he immediately has to claim to the authorities that we have got some intruder between our session, right? So this is the main aim of message authentication code. Now, here, how can I declare that who is sending the data? See, as I have the key, both when I say key concept, so only the authorized users, Alice and Bob, will be having the data key K, right? So CA will be having all the information about that who is taking which keys and all. So now Alice is having K, Bob is having K. Now, if Bob is receiving some combination with K, obviously that is sent by the other party, that is Alice itself, right? So this is what the main aim of MAC combination. See, MAC security, next concept is, MAC security is nothing but just we should be very appropriate with the key whatever we are choosing, because security, if it is weak, we can go with easily we can crack it with many brute force attacks, right? That is nothing but we can try all the possible keys which can be giving this digest to the into the hands of the attackers directly. And we should be aware of the pre-image attack also by this MAC security. Okay, and we have n number of manipulations maybe happen. Immediately we can understand where it is getting striken. I mean, where if the manipulation happens, immediately we'll come to know where to and where to cut it off exactly, right? So this is main aim of MAC and along with this security. Now coming to the nested MAC. Next session is about the nested MAC. So nested MAC is nothing but doing this hashing. I mean the giving this hash function concept message to the hash function and we'll get some message digest. Again we will be, because again we'll be giving the same thing to the another hash function to generate the stronger message digest. So this is very, very important to give maximum security, like to improve the security sometimes. So here we are having the plain text directly with one key, so that we are providing key plus message to the hash function, so that we'll be generated with one MAC. Okay, so this is the intermediate message digest. Now this intermediate message digest will be given as the input to the next hash function with the same key. Now we'll be get with the final digest. So nested MAC is nothing but where the security to be given more importance. I mean more if you feel our channel is more insecure and if you want to go with the twice MAC concept, Then we have to go with the nested MAC, whatever. It depends on the application we are doing, right? Now we have two types of MAC algorithms. So the first one is the HMAC and the second one is the CMAC. Coming to the HMAC, it is totally dependent on the hashing based. Okay, here we are going to concentrate on the hash function properly. Now here, HMAC is nothing but hash-based message authentication code. And the CMAC is nothing but ciphering-based message authentication code. So there we concentrate on the encryption procedure. Here we concentrate on the hashing procedure. So here we are going to give our content directly with the some padding bits. See here, we have plain text. Now plain text M, we will be converting this into equal sized, I mean B bits, equal sized blocks of data first. Okay. So along with this, equal sized data will be given with the key size, right? Now you just do IPad combination first, like input padding. So we call this as input padding. So come to the input padding, do just XOR with the key and B bits will be generated. Now this B bits, M1, M2, M3, so like that all the blocks of data. So M1 take key bits and M1 bits do XOR and you will get M1 bits. Next M2 bits. So like this, you are going to generate all the MN bits. Now after giving all the bits here, you just go with hash function. Okay. So hash function will be giving you one intermediate HMAC. So as we just discussed about the nested MAC, right? So it is similar to that. The intermediate HMAC is given. Now you just take the output padding with the key. So our OPAD also to be given by the input user only. So this should be decided by this may be 8 bits like that. So depending on the bits of the key size, we are going to take the IPad and OPAD size, right? So after this, you will be getting B bits here and this bits and this bits, you're going to provide to the hash function again. Then you will be getting the final MAC function. So this final, you're going to give to the receiver. So this is about the HMAC algorithm. Now, this is what IPad and OPAD to be assumed by ourselves itself. Okay. So K is the key and IPad and OPAD to be enabled by us. So this is the final procedure of HMAC algorithm, right? Now let us move to CMAC. CMAC is very simple. Ciphering will be done. Okay. Ciphering means encryption procedure. So where we call cipher indicates we are going to apply directly, we assume like blankly we can say there is some encryption procedure happening there. So first take your message into a few blocks of data, right? So after taking the data into few blocks, then you apply the encryption algorithm to the first block with the K, your key K. Then the output of this, you do just XOR with your M2, next block of data. XOR and whatever the output you get here, give to the encryption algorithm with the key. Encryption algorithm with the key. Now, whatever the output you get, just to do XOR with the next block M3 here. Okay. Then you just provide this output to the encryption algorithm with the key K. So this will be repeated till all the n number of blocks. So this is what the final output, whatever we get. So the output will be encryption algorithm. Output will be taken and select n leftmost bits. Just give that leftmost bits to the hash function so that you will be generated with the CMAC. Okay. So this is what we are going to analyze the MAC functionalities, right? So HMAC and CMAC are very, very important for our exam point of view. If you have any doubts in this session, you just feel free to contact through comment section or else in the college. Thank you.